Imagine a world where a simple buzz at the door becomes a source of anxiety and exclusion. Traditional intercom systems rely on auditory signals, effectively shutting out those who cannot hear. This creates a significant communication barrier, limiting access to essential services, social interactions, and even basic safety measures. The inability to hear the doorbell or a security announcement can leave individuals feeling vulnerable and isolated. This communication gap extends beyond residential settings. In workplaces, schools, and public spaces, intercom systems are frequently used for announcements, emergency notifications, and visitor management. Deaf individuals are often left out of these crucial communication loops, hindering their full participation and creating a sense of disconnect. The reliance on auditory signals in traditional intercom systems perpetuates a systemic exclusion, highlighting the urgent need for inclusion.
Hello everyone, we are Team Syntax Sorcerers. Our problem statement ID is 1578. In this problem statement, it is given that we have to make a device which would help communicating deaf people. The condition in the problem statement is that the device should operate on zero cost and should be cost efficient and easy to use. The device should increase the manpower of the deaf individual in the organization.
The solution we propose is Vyanjak. It addresses communication challenges for deaf individuals through an integrated system, which includes first intercom device, the yellow device, which has symbol-based UI, as more than 95% of deaf individuals are illiterate. So for them, we have developed symbol-based UI and color-coded notification, where different color will show which person is calling him. And the second device is notification device. The notification device can be wearable in hands, and whenever a alert or notification comes, so the device gets vibrate. It has various vibration patterns which shows the urgency of the message. With the intercom, deaf individual and normal individuals can communicate easily via video calls, group video calls, or can leave a video message if the other person is not available. So there is also a feature of offline AI powered speech to text and hand sign to text. Because what if the other person don't understand hand sign and the deaf won't understand the speech? So for them, this feature is the most important one. The device can also be integrated with various IoT devices such as a smoke alarm, water tank alarm, or even doorbells, which can help individual if the device is used in homes or in any organization. As the whole UI is made symbol based, and there is also a feature of custom scheduling. So custom scheduling is where the user can schedule notifications. Like if it is used in an organization, so the notification can be of lunch break or any meeting or recess or departure time. And when we talk about notification device, so when any alert come, it vibrates and it shows color which depict which person is calling. And the mobile app can perform both the functions of intercom and notification device. Video call can be made easily, notification can be seen.
Now I will discuss the flowchart of our project. As soon we turn on the intercom, it will search for available intercoms within network. After that, we will establish a connection. If our call is not received, we can drop a message in the form of video or text. If our call is answered, we will begin communication. We can also communicate through gesture, for which our AI module will activate. Once the communication is finished, we will disconnect the connection. Technologies and hardware are used: Raspberry Pi 4B, Raspberry Pi camera module, microphone USB, speaker module, ESP32MC, 12C OLED, vibration motor, RGB LED panel, relay module, 3.5 capacitive touch display. Programming languages and frameworks are used: Python 3, OpenCV, TensorFlow, and Android Studio.
When we talk about feasibility and viability of the idea, as the use of components such as Raspberry Pi, ESP32, which are easily available, which make it technical feasible. The hardware cost is low and all the devices are going to work offline. They do not need any internet communication. They're just going to connect to a local network, which can be a Wi-Fi network, and they are going to run. It is easy to set up, flexible, user-friendly, simple base UI is used, and it caters different user groups such as deaf, illiterate, impaired, and elderly. So the potential challenges that we faced first is to make a device which can be used by illiterate people, as there is 60 to 98% illiteracy of deaf all around the world. So for that, the solution we came up with is to make a simple base UI and color-coded notification, as a particular color will show that a particular person who is calling the user. Next is the network connectivity issues. So for that, we can use routers, repeaters, and we can also use inbuilt network of intercom, which can be an ad hoc network. Let's see the impact and benefits of the idea. First, it provides inclusivity, as there is 45% of employment gap between deaf and normal individuals. So with the use of this device, the device let them communicate effectively. It let them to do their work independently. They don't have to depend on any other. So it provides them independence, and it increases workforce in an organization. It can be easily integrated with other IoT devices such as a smoke alarm, so which provides safety and security. There are various sectors where the device can be used. First is education sector. Here students and teachers can use. Employment sector, where it boosts job opportunities for disabled individuals, so which enhances the economy. It can be used in healthcare, as for patient communication it can use and for their care. It can also be used in elderly care, which supports elderly individuals with accessible alerts and communication tools. Thank you.